In a recent video, I showed you a fairly simple freewheel design. The joint slips fairly easily in one direction through a cam action against the spring, but resists turning in the other direction, limited only by the material strength of the freewheel. Alternatively, this could be used as a sort of ratcheting mechanism if the driving force is provided through half of the freewheel. But in some cases, you might want the mechanism to limit the driving force. Perhaps so a machine will not tear itself apart should something get jammed down the line. Potentially even so that the machine is less likely to injure someone should they become the source of that jam. I'm going to modify the design for that purpose now. I'll do that by extending the idea of using a helix to guide the creation of a cutting tool. In the process, I'll show you one method for getting around issues that arise when FreeCAD doesn't seem to like the geometry that you're specifying, in spite of it being perfectly valid. So let's get on with it. I have the final model of the simple freewheel. Start by selecting and hiding the spring in the internal cylinder. Get rid of the fillets and cuts since those are going to have to be redone with the new shape. Also get rid of the extrusion on the cutting tool. Just to make things a little clearer, I'll hide away tube 001 now since we don't need to be concerned with it until later. Make the first tube in the helices visible to give us a good guideline. Just to refresh our memory, the helices have a pitch of 16, a height of 4, and a radius of 3.9 millimeters and 6.1 millimeters. Both are right-handed. So I'll start with creating some new helices. This time I want them to be left-handed so that they'll cut against the part that turned out as a shear wall in the original. I'll set the pitch to 32, making the wall in the reverse direction twice as steep as it was in the slip direction. Keep the height of 4 and the radius is 6.1. I'll just leave the dialog open and create a second helix with a 3.9 millimeter radius. Of course, they're not aligned. You may recall from the previous video that I applied a z-axis offset of 1 millimeter, so we just have to set that for the two new helices. That lines up perfectly. Just like last time, I'll select the two helices and create a ruled surface between them. I'll hide away the tube so you can see it. The original was done with a polar array with a count of 4, so apply the same to the new ruled surface. As usual, reset the center point and OK. Extrude each of the arrays to a default of 10 millimeters, manually selecting the z-axis for the direction, since FreeCAD is not sure what the normal would be for the array. Now to fuse those together so the filleting will apply properly. But here we have an issue. For a reason I never did figure out, only the first instance of the extrusion from the left-handed surface actually appeared in the result. Something about that particular geometry with the arrays seems to have FreeCAD dazed and confused. But since it did get the original instance right, this gives me an idea of how we might proceed. Delete the extrusions and both of the polar arrays. Redo each of the extrusions, once again selecting the z-axis manually for the direction. Fuse them together now. That appears to have produced the correct result. Apply the 1 millimeter fillet to the bottom where they come to a point to give us a nice rounded surface we'll want in the final. Select the fillet and create a draft polar array. Count of 4, reset the center, and OK. Much better. Like last time, bring the tube back, select the tube and the polar array, and cut. Hide away the helices so we can see what we have. Select the cut and fillet. Apply the 1 millimeter fillets to the top points of the shape and OK. That looks much more like what we were hoping for. Like last time, bring in the second tube, select the tube, Select the bottom and cut. And there's our new freewheel with camming action to limit the drive force. Bring the coil spring back and raise the top of the freewheel so it's identical to the way it was displayed in the original. But I think maybe the drive force is too limited here. Fortunately, we have a parametric design. Select the two left-handed helices and increase the pitch to 64. That's exactly what I was looking for. Thank you for watching. If you liked this video or found it useful, please like, subscribe, and share. If there's anything you'd like to see covered here, please let me know in the comments below.